So then another method of doing this is, what if we're rotating more than one function around an axis or a line? What happens then? So in this case, we're looking at the region in quadrant 1 enclosed by the y-axis, cosine of x, which is the blue line here, and sine of x, which is the red. So this kind of shark fin looking region, we're rotating around the x-axis. And what happens with this? Well, if it were just cosine, we'd have a circle for a cross section. If it were just sine, we'd still have a circle for a cross section. What happens if it's both of these is we actually kind of get kind of a bowl shape. I have it right here. We would get kind of this shape. And if we looked at the cross sections, so if I were to do a cross section here, I have actually two circles. And it'd be a ring shape then. So I have an outer circle and an inner circle. And I'd be interested in this region here. And both circles are centered on the line I'm rotating around, which in this case is the x-axis. So to find the area of this shaded region, I'd actually take the area of the big circle minus the area of the small circle. So what I have here isn't a circle anymore, but it's a washer or a ring. Typically we call them washers. So for my big circle, its radius is the y value for the outer function, which is cosine of x. The radius of the inner circle is the radius of the lower function, or the y value there, which would be sine of x. So if I wanted to find the area, it'd be the area of the big circle minus the area of the small circle. And that gives me the area of my cross section. Well, then the volume just accumulates that cross section. So I take the integral of the area of my cross section. Now for the bounds, these are with respect to x. Because it's in the first quadrant, the lower bound is an x of 0. The upper bound is where sine and cosine intersect, which would be at pi over 4. And so when I then calculate this volume integral, I would get 1.571 units cubed. As far as, just like with disks, washers have kind of a generic equation that we can use when rotating around the x-axis. We'll deal with in class on a later day what happens if it's not around the x-axis, what if it's around the y-axis, or what if it's around another line entirely. But around the x-axis, like with disks, we have kind of a generic formula for this where all they did is what we did, they just pulled the pi out because it's a constant multiple.